In this video, I will show you how to make the LED blink on the Microstick II. You will need a Microstick II and install the PIC24FJ64GB002 chip onto it. You will also need the MPLAB IDE and the XC16 compiler installed. Here is a schematic of the Microstick. On pin 2, it goes to a jumper and then to an LED, which will be the one that we will light today. Here is a picture of the Microstick 2. The jumper is the black thing on top, and then the circled part is the LED. Here is the pinout for the PIC24FJ64GB002. Pin 2 is located on the upper left hand side and has many functions, but the one we're looking at today will be RA0. The method of control will be the port A register, which is connected to the RA pins. RA0 is on pin 2. To illuminate the LED, the voltage on pin 2 needs to be high. As you can see, pin 2 has RA0. Here's the code. We'll need to include our microprocessor header file. So the P24FJ64GB002.h file. We'll open up an int main. We'll set the tri-state TRISA. We'll set that to 0. This makes all the pins outputs for the port A. We'll define a variable I, set it equal to 0, and we'll open up a while loop, which will set to repeat forever. The first instruction will set port A to 1, which will drive the RA0 since it is the least significant bit to 1. Then we'll set a delay loop up right here. It'll count to 30,000, and then that'll be long enough for us to see a difference when it goes to 0, which will turn off the LED. It'll delay again and go back to 1. The LED will turn on and off. Okay, let's open up MPLAB. Let's make a new project. We'll click on the orange folder. We'll go to Microchip Embedded, Standalone Project. We'll type in our chip, which is the PIC24FJ64GB002. For the tool, we will be using the simulator today. Simulator. Click Next. Choose our compiler, the XC16. Next, project name, call it example. Finish. Let that load. Alright, we'll open up example. We need to add our header file, so we go add existing. This will be located in our C drive. Go to program files, microchip, XC16, support, PIC24F, H for header files, and then we scroll on over to the PIC24FJ64GB002, which is this one. We hit select. That'll move our header file up into the header files. Then we need to make a source file. So new, other, C source, and we will call this our main route. Finish. Alright, so left with that. Now we will start writing the code. First thing we need to do is add the header file. Go to hashtag include quotation marks E24, look over here, FJ64 GB002. On that, press enter, do. We gotta make our main subroutine int main void, put up our brackets, and our first code will be to set the tri-state resistor ERISA. We're gonna set that equal to 0x0000 and put a semicolon. Then we're gonna define our integer I and set that to 0. Semicolon. We're gonna make our while loop. WHI. And we're gonna make it true. We're gonna put our brackets. And in this one, we're going to set port A equal to 0x01. Close it. Make another while loop. While. And in this one, we're going to make it true when I is less than 30,000. Then we're going to increment I plus. And then I'm going to exit this loop, come down here and set port A. We're going to set that to 0x0, and we're going to make another loop. We're going to set I back to 0. Make another while loop. While I is less than 30,000. And then we'll put I plus plus, and we're going to exit the loop and set I back to 0. So when we restart, there'll be an this while loop will take 30,000 cycles before it moves on to this part again. Alright, so that's everything. We'll compile it, debug it. No, there's an error. We forgot a semicolon somewhere. It says, main project produced error, expected semicolon before bracket. So we forgot our semicolon here. Alright. And we got X success. Okay. Alright, so you would load this onto your Microstick, but I only have 2 USB ports on my computer, so I can't use my mouse and keyboard and the Microstick all at the same time. So stop that. Set it to 100 so I can show you on the simulator what is happening. Alright, so it worked. Where's this window? Go to Windows, Simulator, Logic Analyzer. We'll click on Settings, scroll down to RA0, click Choose, OK, and we're going to set breakpoint here on line 9 and here on line 16. So we'll run it. Alright, it's working. So we can see that the voltage for RA0 is 0 volts. We'll step it, and then you can see that it has gone up to 3.3 volts, and it has taken 40 to 600 cycles to get to the next line 15. So it took 600 cycles to go with 100 loop delay, and then we'll hit next again, and you can see as it has gone back down for another 600 cycles. Go into Settings, Properties, and we can change it to time instead. So let's do another step. So from 650 to 1250 is 600 microseconds. Yeah, 600, about 600 microseconds, which is very short. The LED would be you wouldn't see any blinking if you had a delay of 100 or 100 in here. So you need to make it 30,000 to see the LED blink. Here is a video of the microstick blinking.